If you've ever heard terms like digital twins, smart buildings, generative design, or anything about AI in construction, they all have one thing in common. None of them really work without BIM. BIM is the foundation of digital construction, but despite being one of the most important concepts in the industry, it's also one of the most misunderstood. BIM is an acronym that stands for Building Information Modeling. People often think BIM is just a 3D construction model, or sometimes they think it's a piece of software, but BIM is a process. In fact, some people refer to it as Building Information Management, and personally, we think that's a more accurate representation of what BIM is. The reason BIM exists is because construction is incredibly collaborative. Even a relatively small project might involve several different specialists, architects, engineers, contractors, suppliers, clients, and the list can go on. And all of them need different information. The problem is that they've often been working from different versions of it. One person has a spreadsheet, someone else has an updated version. One team is working from one set of drawings, whilst another team is working from something completely different. Someone might change the location of a door and update the layout drawings, but not the structural drawings. So now there's a hole for a door that's moved. This then leads to delays, rework, and extra costs. That's why BIM exists in construction. At its core, BIM is really about managing information so that the right people have access to the right information at the right time. Now, in architecture, engineering, and construction, a single project will generate incredible amounts of data. Some of this data will be stored within a BIM environment, but there's still lots of information that lives outside of the model itself. And this is where the Common Data Environment, or CDE, comes in. The Common Data Environment aims to be the single source of truth. It's where project information is collected, managed, and shared. This includes not only the information you would get from a 3D model, such as what it looks like, the shape of things like walls and doors and where they're positioned in space, but also the descriptive information you need to support it. Things like fire ratings, manufacturer specifications, maintenance information, and commercial data such as costs. But then what's the difference between BIM and the Common Data Environment? Well, BIM is the process or strategy for how we manage digital information, whilst the CDE is the platform where that information is stored. The CDE enables your BIM strategy. Let's take a song as an example. BIM is the actual track. It's the music, lyrics, instrumentation, and audio files created by the musician. Whilst the CDE is something like Spotify, Apple Music, YouTube Music, or SoundCloud. It's the platform where the tracks are uploaded, stored, and organized into albums. This is how music gets updated and distributed so that all the fans are listening to the exact same version. And just like how a singer, a drummer, and a saxophonist all contribute different elements to a song, an architect, an engineer, and a contractor can all contribute different elements to a BIM model. And if an artist decides they want to change the chorus or a lyric, they can upload a new version that everyone can listen to straight away, as opposed to in the past where you'd be stuck with whatever CD or mixtape you happen to buy at that moment in time. And again, it's the same in construction. If an architect moves a door, updates the specification, or changes part of the design, everyone can access the latest information rather than working from an outdated file. But BIM isn't just about storing and sharing information, it can also connect different types of information together, and that's where the different dimensions of BIM come from. Historically, we had 2D drawings, and then along came 3D. You take the X and Y of a traditional drawing and add the third dimension in space, allowing you to better visualize what you're building. After that comes 4D BIM, where you add the construction schedule. This includes the duration and timing of when things are getting done, and also includes the logistics, so what's getting done first, who's working where, and where on site are things getting delivered. It's useful for identifying clashes not just in the design, but in how the project is actually going to be built. Then there's 5D BIM, where cost information is added. Now you can start linking the model to budgets, quantities, and project spend as work progresses. Beyond 5D, you may hear people talking about 6D, 7D, or even 8D BIM. The exact definitions vary depending on who you ask, but they generally relate to things like sustainability, facilities management, and safety. The important thing isn't really the number, it's that BIM allows information to be connected together in ways that help people design, build, and operate assets more effectively. And that's why BIM is the foundation of digital construction. Because at the end of the day, construction isn't just about concrete, steel, and machinery, it's also about information, and BIM is how the industry manages it. We've now covered what Contech is, why technology adoption is difficult, how construction actually works, and finally, the digital foundation that underpins it all. Next, we're going to start looking at the technologies themselves.